Good afternoon, my YouTube viewers. This particular video, we're going to be talking about hypothesis testing and how they relate to sample distributions. So by comparing the observed sample statistic to the sampling distribution under the null hypothesis, researchers can determine the likelihood of observing such a statistics by chance. So the code that we're going to be going over now is we're going to create a normal distribution and then we're going to hypothesis test it. So the first thing that we need to do is we need to import the libraries that we're going to use to create this distribution and perform a hypothesis test. So we're going to import NumPy as NP, which is the numeric library. We're going to import matplotlib.pyplot as PLT, which is the visualization library. And from SciPy, we're going to import stats. And stats is the statistical module within the SciPy library. So then what we're going to do is we're going to generate the population data. So the first thing that we want to do is we want to set our seed. So basically, what happens when you set your seed is you initialize the values. And so every time you run the program, the values will be set to the same initial values when you use it. And that's the purpose of setting the seed. So we're going to define our population as np.random.normal. Loc is your mean of 50. Scale is your standard deviation of 10. And size is your sample size of 10,000. And this is going to be a normal distribution that you're going to be creating. So we're going to set our parameters for sampling. So the sample size is 30. The number of samples is 1,000, and the hypothesized population mean is 52. So they're saying that the population mean is 52. So now what we do is we collect our sample means. So your sample means is an empty list. For underscore in range, num samples, so that's 1,000. Sample equals np.random.choice, brackets, population, comma, sample size, and replace equals false. So that means whenever you take a sample, you don't replace it. So sample mean equals np.mean sample, so that's the sample of the mean, and sample means.append sample mean. So every sample mean that you get, you're going to append it to this list called sample means. So you're going to have a list of 1,000 sample means in the list called sample means. And we're going to perform a one sample t-test. So t-statistic, comma, p-value equals stats.t-test underscore one sound. Bracket sample means, comma, hypothesized means. And then we're going to plot the distribution of the sampling distribution of the sample mean. And we're going to do that by creating a histogram. So plt.hist, brackets, sample means, comma, bins equals 30, comma, color equals sky blue, comma, edge color equals black, comma, alpha equals 0.7. plt.axv line, brackets, np.mean, sample means, comma, color equals red, comma, line style equals dashed, comma, line width equals 2, comma, label equals mean. And then plt.axv line, brackets, hypothesized mean, comma, color equals green, comma, and line style equals dashed, comma, line width equals 2, comma, hypothesized mean equals, the label equals hypothesized mean. And then plt.axv line, brackets, np.mean sample means plus t-statistic times np.std sample means divided by np.square root len sample means, comma, color equals purple, line style equals dashed, line width equals 2, and label equals t-statistic. So what in this one, what you've done is you've created your t-statistic as well. Or you put it on the histogram. So now what we do is we add our titles and labels to the histogram. The title is hypothesis test and sampling distribution. Sample mean is your X label. Frequency is your Y label. And you get a legend. And then we're going to display the chart. And we're going to print the test result of the t-statistic and the p-value. So the t-statistic is neg 33.90 and your p-value is 0. So basically, if the p-value is less than 0.05, that's 5%, then that means you reject the null hypothesis. So that means since the p-value was 0, the null hypothesis is rejected. So that means that you have to accept the alternate hypothesis. But we haven't set up hypothesis yet, even though we're doing hypothesis testing. So the mean is 50 because you set the normal distribution up to have a mean of 52. And the hypothesized mean is actually the population mean of 52. So the mean is, the sample mean is 2 points away from the hypothesized mean. And your t-statistic is negative 33.90. So that concludes this video on hypothesis testing distributions, and the next video we will talk about another sample distribution related matter.